Let's talk about attributes of functions. We're going to talk about several key attributes throughout this unit and, of course, the rest of the year. The first one that's really important is for you to understand intercepts. The second one is asymptotes. The third is max and min. And then fourth is symmetry. We're going to discuss the intercepts and asymptotes now. We will work through the maxes and mins on some problems, and we will do more symmetry, a lot more symmetry, later in the year. Let's look at what the intercepts are. The intercepts are where the curve intercepts or crosses the axis. So the x-intercept is where it crosses the x-axis. And of course it crosses the x-axis where y is equal to 0. So when you're given a function, like this function, y is 2x plus 1, to find the x-intercept, you set y equal to 0. So if my function is y is 2x plus 1, to set y equal to 0, everywhere I have a y, I put in a 0. So 0 is 2x plus 1. I'm going to solve this for x. So I'm going to subtract 1 from both sides. So negative 1 is 2x. To get 2 by itself, I'm multiplying. So I'm going to divide. And I'm going to move this over here because I like it that way. So the x-intercept is when x is minus 1/2, or in this case, to put it in point notation, it's negative 1/2. 0. The y-intercept is where the curve crosses the y-axis, or when x is equal to 0. So to find the y-intercept, you set x equal to 0. So again, I have my function. Y is 2x plus 1. Everywhere I have an x, I'm going to put in 0. So y is 2 times 0 plus 1. Where y is 2 times 0 is 0. So the y-intercept in this case is when x is 0 and y is 1. Asymptotes are really, really cool. We have two types. We have horizontal asymptotes and throughout the year, I'm going to call these HAs. They're funny. Haha. Horizontal asymptotes. And a horizontal asymptote is a line y equals, in this case, it's y equals 0, where the curve approaches it, and after a certain point in time, it doesn't cross it. We can have wiggles over for a while, and we're going to address those a lot more in pre-calc, in calculus. A vertical asymptote is a line, in this case, the line x equals 0, where the curve in this cannot cross at all. In this, as we see, as we approach 0, x equals 0 from the left, it becomes infinitely unbounded in the negative direction. As we approach it from the right, it shoots back off to positive infinity. So you're going to have vertical asymptotes when you have these undefined points.